Imagine a strategy that looks steady on one historical split. Its test period may contain a clean trend, friendly volatility, or a fortunate trade sequence. Choose another fair chronological split, and the picture can change. Markets arrive in order. Time is not interchangeable. The question is not whether one out-of-sample window was good, it is whether evidence survives many credible calendar cuts. CPCV begins with one ordered history, not shuffled rows, divided into 8 consecutive blocks, and hold out 2 at a time. Each held-out union is one test path. The other blocks are a training side only when a model is fitted. 8 choose 2 gives 28 candidate test unions. Instead of one split, inspect the distribution of test path behavior. Protect a real handoff. If a training observations label or evaluation window overlaps the test boundary, purge it. Leave an embargo gap after the boundary so nearby information cannot leak forward. These steps matter only when training or selection uses the training side. They are data hygiene, not a performance statistic. Size the gap from label horizon and market process. Current boundary, the return-only evaluator, calculates each test fold sharp from held-out returns. It does not refit a rule or select parameters with paired training indices. Output is a distribution of test fold return sharps. The split builder creates a coarse observation count buffer around the combined test span, but that buffer does not change this score. Do not call it a fully purged refit. Clearly illustrative. 8 blocks and 2 held out produce 28 candidate test unions. Suppose 18 have positive annualized sharp. 18 divided by 28 is 64.3%. A local 60% operator line clears in this toy. That line is a configured gate, not a statistical law or a current result. It says nothing about a train and refit procedure that never ran. PBO asks a different question. Canonically, start with multiple configurations and contiguous time slices. For every equal in-sample and out-of-sample half-split, choose the best in-sample configuration. Then ask where that selected configuration ranks out of sample among every configuration. This tests whether apparent winners repeatedly fall at or below the OOS middle after selection pressure. Turn the OOS rank into R. Then a logit. Lambda equals the natural log of R divided by 1 minus R. A lambda at or below 0 means the selected configuration sits at or below the OOS median. PBO is the fraction of symmetric splits with that outcome. It is about selected configurations and ranks, not a sign change in one return series. Fully disclosed toy, 4 configurations, 4 blocks. IS scores A1.6, B1.3, C0.9, D0.4. Select A. Paired OOS scores A0.1, B0.9, C0.3. A ranks 1/4. Teaching convention R reval 1-4 plus 1 is 0.2. Avoids endpoints. Lambda equals ln 0.2000 part 80. Minus 1.386. Across 6 toy half splits, OOS ranks 1, 2, 3, 4, 2, 1. Put 4 logits at or below 0. Illustrative PBO equals 4/6 or 0.677. Unitless teaching values, not a paper replication or market result. Today's PBO-labelled route is narrower. 1 return series, 8 segments, 4 versus 4 halves, 70 comparisons. It counts an IS positive, OOS negative, sharp flip. Toy 2170 equals 0.30 below a local less than 0.5 operator line. It is a temporal sign flip proxy, no configuration selection, OOS ranks, or canonical rank logit statistic. Do not treat overlapping combinatorial paths as new independent market histories. Do not size an embargo by aesthetics. Tie it to label overlap and information flow. Do not tune a gate after seeing its paths. Do not rename a narrow proxy until it resembles a stronger paper result. Trust grows when a method preserves what it actually did, including its limits. A positive test path distribution can narrow concern about one chosen calendar. A canonical-style PBO calculation asks whether an in-sample winner repeatedly ranks below the OOS middle. Neither proves future profit, regimes, costs, stability, execution, capacity, or later evidence independence. A local clear is not a license to trade, it is one reason to keep asking harder questions. Use an honest order. Define configurations before selection. Preserve chronological blocks. Size, purge, and embargo from the information boundary. Fit only on the training side when fitting is part of the test. Show the held-out path distribution. If you claim canonical PBO, show selection, OOS rank, and logit. If you use a proxy, name it. Then seek new independent evidence. No current result is needed.